Okay, on the last video I apologize for the volume and the noise in the background. But what I want to go back to is these summation formulas and make sure that you guys hear that you don't have to memorize these for tests or quizzes. I will give you those summation formulas. You just need to apply them to the problem. So if there's an I, you replace it with an n times n plus 1 divided by 2. If there's an I squared, you replace it with an n times n plus 1 times 2n plus 1 divided by 6. If there's an I of the 3, you replace it with an n squared times n plus 1, quantity squared divided by 4. I got cut off and I didn't finish the problem on the last video, so I do want to go ahead and do that. When you complete this fraction, you get 14,400 minus 240 for the final answer of 14,160. There's one more thing on this set of videos that we're going to talk about, and that's like what I was saying. This is the beginning parts of area underneath a curve. And area underneath a curve is really what we're doing when we write integration. We're going to get into that much further and in much more greater detail as this chapter continues. But for right now, what we're going to be doing is estimating underneath the area underneath a curve. What we're going to talk about is lower sums. We're going to use lower sums on this one, and we're going to use upper sums on the second one. So you can see I may be using the same graph, but I'm going to make a lower sums and upper sums. So I'm going to talk about how to draw in the rectangles first. Lower sums are all the rectangles will be below the curve. So it says I'm supposed to make rectangles with width of 1. So that means that I will have 4 rectangles maybe. Maybe 4 rectangles, maybe not. To make this rectangle go underneath the curve, okay, I wouldn't use this dot up here because then my rectangle would extend above the curve. So I'm going to use the rectangle below it and draw a line right across from that dot. The same thing for the second rectangle. I want to make it go below, and if I use this dot, I'm going to have a rectangle above, so I want to go ahead and use this dot right here. And then my third rectangle, this is the dot I will use and go across from. Again, if I use this one, I'd be above the curve. And then this last one isn't a rectangle at all, because if I go above it, I'll use this dot, I'd be above the curve. That's not a lower sum. I would have to use the dot down here, which actually makes the area of that rectangle 0. So I'm going to go ahead and continue to talk about how to draw these, and I'm going to skip to the second problem, which is upper sums. And notice I have the same picture drawn. The upper sums are rectangles that are drawn above the curve. So again, I'm still going to be using those rectangles with a width of 1 because that's my instructions. This time, though, when I make my rectangle, I'm not going to draw this rectangle in. I want to draw above the curve. That's an upper sum. So again, on this side, I'll use this upper point and make it go above the curve. Again, above the curve for my rectangle, and then above the curve again. This is the upper sums. So let's go back to this last drawing, and what we're going to do is we're going to find the area of each of the rectangles, and then we're going to add them together, and this is going to be our approximate area for the area underneath the curve. So the area of this first rectangle, all the areas for the rectangles will be length times width. So the length of it is 4, and the width of it is 1, plus the second rectangle here. I'll go ahead and put that as a red. So this is my black rectangle. The red rectangle has a length of 4 and a width of 1. My green rectangle has a length of 2 and a width of 1. And then my last rectangle isn't a rectangle at all. So I end up with the area being approximately 10. The second problem for the upper sums, we're going to go through the same thing. We're going to have the area equals length times width. The area is approximately, the length of the first rectangle is 5 and the width is 1, 5 times 1, plus the length of the second rectangle is 5 and the width of it is 1. The length of the third rectangle is 4 and the width of it is 1. Plus the last one, the length of it is 2, and the width is 1. So I end up with 5 plus 5 plus 4 plus 2, which gives me an approximate area underneath the curve of 16. Neither one of those are correct, they're just approximation.